Hello everyone, this is our presentation on the automatic plant irrigation system. So first of all, we will look at the background and motivation of this entire project. With this project, we aim to address problems like water scarcity, promoting sustainable agricultural practices and enhancing resource efficiency while primarily optimizing plant growth and yield. In our hustle bustle of today's lives, we aim to make this plant watering system very easy and hassle free for our users. By leveraging technology and intelligent control systems, these systems offer significant benefits to farmers. This is our schematic setup. This is involves the channel relay, the water pump, the soil moisture sensor, the node MCU, and the DHT11 sensor. The components used are these, as well as ThinkSpeak and MIT App Inventor, which helps us to integrate and add special features like data analytics as well as the user interface of the app. Now, moving on to the several components like DHT11. DHT11 is a widely used digital temperature and humidity sensor. It converts the analog readings to digital by itself. There are very many alternatives like DHT22 and DHT21. It has 4 pins: VCC, data, NCC, and ground. And this is a very efficient humidity and temperature sensor which sends the values to the ThinkSpeak platform. Now we have the Node MCU. Node MCU is an IoT development board based on the ESP8266 microcontroller. The Node MCU basically brings the entire project together. It integrates the entire project together by sending the readings to the ThinkSpeak and the MIT app, and also helps to just make the entire project fully functional. Now, moving on to the MIT App Inventor, which we had used to make our very user-friendly app for which could be used by farmers also who do not have much technical experience or knowledge. It is a web-based tool developed by MIT that allows users to create Android applications using a visual block-based programming interface. Now, this is the circuit diagram for our project, and this is how we made the connections. Moving on, we also coded a program so that our project is fully functional. These were the things, these were the components of the code. The libraries which we imported were ThinkSpeak, ESP8266 Wi-Fi, Wire, and Liquid Crystal I2C. ThinkSpeak was for the IoT platform. ESP8266 Wi-Fi was to establish the Wi-Fi connection for the the Node MCU module. The DHT's library was to record the humidity and temperature recordings from the DHT11 sensor, and liquid crystal I2C was to display it on the LCD display. Along with all of this, we also use ThinkSpeak integration, the code sensor into the ThinkSpeak platform using HTTP post request. Motor control, the code controls the motor connected to ESP8266 to the D7 pin, and the motor is used for watering the plants based on the soil moisture level. These used several delays and loops in the code so that we can control the timing of sensor readings and data transmission. Serial communication was utilized to print debug information such as sensor readings and system status. Calibration was used to define the values for soil moisture, specifying the thresholds for considering the soil as wet or dry. Now, of course, during the entire project, we faced several challenges, but we also found the solution. The challenge number one was to manage project costs and budget constraints. Now, we were given a budget constraint of 1500 rupees. We did a cost benefit analysis to evaluate the system's long term advantages and potential return on the investment. Not only that, we found the best efficient components that we could use, like the DHT11 sensor, which is probably the best humidity temperature sensor which would come in our budget. Now, moving on to a second challenge. We wanted to ensure user acceptance and effective training. Farmers and agricultural workers may have limited technical experience and may be resistant to adopting new systems, and that is why we had to make an app which was easy to use and user friendly, and that was done by using the MIT Inventor app, which was also easy for us to create as it is a very easy prototype to make using that app. The third challenge that we faced was handling and analyzing large amounts of data, and this was This was combated with the help of the ThinkSpeak platform. We wanted to implement a robust data management system to organize and store the data. With a plant irrigation system, a lot of values and a lot of data is involved, and we need to properly analyze such data, and that is why we used the ThinkSpeak platform. Now, this was the photograph of the final system. This was the product of all our hard work. And yes, now moving on to the next, we also learned a lot from the project, including the importance of sustainable practices in agriculture, integration of technology for efficiency, problem solving and innovation, data driven decision making, collaboration and expertise. And throughout the project, we learned continuously and adapted to the various problems that we faced along the way. Now, who did what? My teammates Asif and Sumed built and assembled the circuit and other components of the project, while Balaji and I worked on the code and the app of the project, and also we made the presentation. In conclusion, this project is an innovative and effective solution for addressing the challenges associated with plant watering, and will be a huge boost to the agricultural industry. These were the references we used. Thank you.